Hello, everyone. Today, I'm going to explain what game theory is in mathematics. Have you ever had to make a decision while considering what someone else might do? Maybe you were playing chess, deciding whether to negotiate for a better deal, or choosing which checkout line at the grocery store would move fastest. Whether we realize it or not, we engage in strategic decision making all the time. This is exactly what game theory studies, a branch of mathematics that analyze how individuals or groups make decisions when their choices depend on the action of others. Game theory was pioneered by mathematicians like John von Neumann and John Nash, and it has revolutionized fields like economics, politics, biology, and even artificial intelligence. In this presentation, I'll explain the fundamental concepts of game theory and explore a real-world application in economics and business. What I'm about to talk about next is the fundamentals of game theory and what it consists of. At its core, game theory seeks to answer the question, what is the best strategy when multiple decision makers interact? A game and game theory consist of three key concepts. The player. This is the decision maker in the scenario. This could be individuals, companies, countries, or even animals in evolutionary competition. Next is the strategies, the different actions each player can take. And then the third option that consists in game theory is the payoffs, the outcomes that result from different strategy combinations, which can be rewards, profit, or even consequences. The types of games in game theory, which I will explain. Game theory covers many types of strategic interactions, including cooperative versus non-cooperative games, which consists of cooperative games, which is players can form alliances and negotiate. Example, trade agreements. In non-cooperative games, players act independently, like firms competing in a market. Next, there's zero-sum versus non-zero-sum games. In zero-sum games, one player gains is another one's loss. Example would be poker. In non-zero games, all players can benefit or suffer together, like climate change negotiations. Within game theory, there's something called the Nash equilibrium. One of the most important concepts in game theory was named after John Nash, the Nash equilibrium. A Nash equilibrium occurs when no player can improve their position by changing their strategy alone. Everyone has settled into their best possible move given what other players are doing. An example of the Nash equilibrium is something called the prisoner's dilemma. Imagine two criminals, Alice and Bob, arrested and interrogated separately. They have two options. Stay silent, which is cooperating with each other, or betray the other, which is defecting each other. If Alice stays silent and Bob stays silent, both get 1 year in prison. If Alice stays silent, but Bob betrays Alice, Alice gets 3 years and Bob goes free. If Alice betrays Bob and Bob stays silent, Alice goes free, Bob gets 3 years as well. If they both betray each other, they both get 2 years. In this scenario, the best collective outcome is for both to stay silent, which they each would get 1 year of prison time. However, if each person betrays rationally in their own interest, they will both choose to betray. 2 years each would be the sentence. This paradox illustrates why cooperation can be difficult, even when it benefits everyone. The prisoner dilemma applies to real-world situations like arms races, price wars, and environmental policies, where individuals' incentives can lead to bad collective outcomes. The following I'm about to talk about is a real-world application of game theory, which is involved in economics and business. Game theory is widely used in business and economics to model competition, pricing strategies, and negotiations. Let's explore a common scenario, which will be price wars in soft drink industry. Imagine two major soda companies, Coca-Cola and Pepsi, competing for customers. Each company must decide whether to keep prices high and maintain large profit margins, or lower prices to attract more customers. Let's say Coke keeps prices high and Pepsi keeps prices high. Both keep profits high. If Coke keeps prices high and Pepsi lower prices, Pepsi gains more customers, Coca-Cola loses. If Coke lowers its prices and Pepsi keeps its prices high, Coca-Cola gains more customers and Pepsi loses. If they both lower prices, they both have lower profits. So if both companies keep prices high, they both win with high profits. If one lower prices while the other doesn't, the company will lower prices, will win more customers. If both lower prices, they maintain market share but lose profits. This situation resembles the prisoner's dilemma. While corporation keeping prices high would benefit both companies, but the fear of losing customers will force them into price cutting, which lowers profits overall. Other examples of game theory in economics and business is auctions. Companies use game theory to strategize in bidding wars, like Google ad auctions. Another example is negotiations. Businesses analyze competitors' possible response before making deals. Product launches. Firms anticipate how rivals react to new products. Supply chain management. Retailers use game theory to decide pricing and stock levels. Overall, game theory doesn't just apply to business. It's used in sports, politics, military strategy, and even biology, where animals compete for resources using strategic behaviors. Overall, to summarize, game theory is a powerful mathematical tool that helps us to understand decision-making in competitive and cooperative environments. It applies to economics, politics, biology, and even everyday life. As spoken about, the Nash equilibrium shows how each player settle into stable strategies. The prisoner's dilemma and business competition reveal how rational choices can sometimes lead to suboptimal outcomes. Next time you face a strategic decision, whether it's negotiating a deal, competing in a game, or deciding how to split a group project, think about the games being played. What are the possible strategies and payoffs? Or even thinking about the less winnable outcome. By applying the game theory, you might just make smarter decisions and predict the actions of others more effectively. Overall, the game theory is a very interesting and strategic way to go about thinking about difficult situations when you're interacting with others in everyday life. I think it is a great resource to think about and know about in mathematics and in decision making and very suitable outcomes or something that might affect a business or something later in life. Thank you for watching.